Hello everyone, this is for the practical part of the lab, how we have to write the VHDL codes for each of that. Okay, so the VHDL codes are in the three experiments. One is adders and subtractors, multiplexers and JK flip-flop. Okay, so in these three we have the adders and subtractors. So in adders we'll have the first one, half adder. That's very easy. We'll write the begin and end behavioral, and inside that we'll write the equation of sum and carry. Okay, then we have full adder. Similarly, we'll write the sum and carry for the full adder also. Similarly for half subtractor and full subtractor also. Now the next part is multiplexer. Inside the multiplexer you will start with S select, then Y is the output. Okay, what is D0? See here, see D0 should be selected when the input is 0. So see here in multiplexer you will have total 8 inputs. Okay, now D0 should be selected when the input is 0 0 0. These are the inputs A, B, C. So when it is 0 0 0, D0 should be selected, right? So that's what we are specifying here. D of 1, which is this one, that should be selected when it is 0 0 1. Okay, that's all what we are specifying here, and the output should be gone to Y. Okay, and that's it in the multiplexer part. Coming to the JK flip-flop, it's a bit hard. Signal input. Okay, input is a signal used. That's a variable input, and it has values from 1 to 0. Okay, 1 or 0, these are the two values for the inputs. Now why we have taken the inputs? See, in JK flip-flop it is nothing but, see, if it's a JK flip-flop, this is the J value and this is the K value. The output will be Q and Q bar. Okay, now if J is 1, this Q will become 1. Okay, if K is 1, Q bar will become 1. Okay, and these two are the opposites. When Q is 1, this Q bar will be 0. When Q is 0, Q bar will be 1. Okay, it's the opposite. Now if both are 1 here, then at the same time if both J and K are 1, just the value will be altered. Okay, suppose that Q is equal to 1 and Q bar is equal to 0. Then what I did is I will make the J also and K also 1, so it will shift the value here. Okay, means Q will become 0 and Q bar will become 1. That's all what we are specifying in this code here. Let's see how it's getting specified. Now start from here, begin, input. What are the inputs? J and K. So J and K are getting in the input. Okay, see here, 1 down to 0. One is for J and another is for K. Okay, so it can have values from 1 to 0. Then process, CLK, clock, J and K, preset and clear. Okay, this you have to mention inside the process. Then variable temp, standard logic is equal to 0. Temp is another variable which will have the value as 0. Okay, temp is used for setting the Q and Q bar value. Okay, then we will use here begin if CR is equal to 1 and PR is equal to 1. When clear and preset both are high, then only this circuit will work. Okay, JK flip-flop works only when clear and preset both are high. Now then after that, if both are high, then we have to check if the clock is 1, because when the clock is 1, then the output changes. Okay, when clock is 0, the output remains same. Now if clock is 1, then what we have to do, we have three cases here. When J is 0, when J is 1 and K is 0, these two are the input. Okay, see, these two are the inputs, 1 and 0, and input had J and K, right? So J is 1 and K is 0. When J is 1 and K is 0, at that time temp should become 1. Else if it is 0 1, temp should become 0. Means if it is 0 1, okay, if it is in this form, J is 0 and K is 1, temp should become 0. If it is 1 1, temp is equal to not temp, means it should reverse the value. If temp is equal to, if temp is 1, then when J and K both are 1, temp should become 0. Okay, that I told you. In JK flip-flop, if both J and K are 1, it should reverse its value, right? So temp will become not temp. What was temp? It will become the reverse value of that. Okay, the else is this: if clear and preset are 1, then only these things should execute. If it's not 1, then the execution will not happen and temp will be remaining 0 only. Then end if, then Q is equal to temp. Now see, we got the Q value, right? We got the temp value for setting the Q value. Now temp was, suppose this is the JK flip-flop. Okay, this is the J and this is the K value, this is Q and this is Q bar. Okay, now when J was 1 and K was 0, that means if J is 1, Q should become 1, right? So when J was 1 and Q was 0, temp was 1 in the first line. Remember, temp is equal to 1. When J is 1 and K is 0, temp was 1. See here, when this is the input, which is J and K value. When J is 1 and K is 0, that time temp is 1. So temp should become Q value. q value is equal to temp, that means q will become 1. Okay, see this 1 will go and get placed in q. That's what's happening here, q temp. Else if it is 0 1, j and k, if it is 0 1, it should be temp should be 0, temp will become 0. The second line inside that, see here, temp will become 0 and q will become 0. Okay, when j is equal to 0 and k is equal to 1 means q value should be 0. Okay, and in case q bar is also there, right? So q bar is not temp, means it whatever value of temp is in q, the reverse value of that should be in q bar, so not temp here. That's it, that ends the process, and this is the code for the gk flip flop. Okay.